So we solved this similar question from the previous session where we were trying to find a limit from the graph. So here we are also going to do the same thing. Find the limit as x approaches -2, -1, 0, 1. Right? We are going to do it for all these 4 points. But we had a trick from the previous session, right? We said that the first thing is like when you go to the point, you need to draw the an imaginary line passing through that particular x-axis point. So here the x approaches these values are located on the x-axis. So here for this case, the horizontal axis is not labeled as x, right? So it's going to be t. So instead of writing x here, we should rather write t. T approaches negative. So whatever is on the vertical axis is what label we give to the limited approach that particular point. So on the t axis, which is the horizontal axis in this case, we need to find locate the individual points like these ones. So we have -2 here, we have -1 here, we have 0 here, and then 1. So what will give us an idea automatically, maybe in case you are solving section A, right? So what you do is that you just draw your imaginary line like how you did it through 0. 0 is here, so x is equal to 0. So this is this imaginary line. So you see that um let's do for 1. 1 is also here. The imaginary line until it's cut the axis. So it's here. And then we go to -1. -1 is here, right? Also cut in this way. -2 is here, so through the negative vertical line. So you see that we said when we are doing this, after doing the imaginary line, where the imaginary line cuts the axis or join the cuts the graph in two or more points. At that point, we say that the limit does not exist. So you see that -1, no, at x is equal to 0. When you draw the imaginary is cutting the graph at this point and at this point. So it's cutting it in 2 points. For this reason, this place does not exist. So the limit does not exist at this point. That's what we are going to get for this particular function. But for the other point, the limit is going to exist. So basically, to do that, so this is where this particular imaginary line cuts this x-axis, and then we are going to read that value from y. So here is going to be 1. The value is going to be 1. So the limit as f of t t approaches 1 is going to be 1. So you read that from this way it cut the imaginary line through 1, cut the graph, and it's at 1. So you just basically put it there. This is the trick, but then we took our time for the previous session to explain how it's actually obtained by trying to draw it from two separate lines. But right now that we have understood, we are going to use this session to just use a trick so that we can be fast and quick. For this particular one, the imaginary line passes through this one and it's cut only at 1 point. So that 1 point, we read that point value from the y-axis, and the y-axis is referring to -1. So the limit at t approaches -1, the answer is going to be -1. So these are the y values. What we have here are the y values. What we have here are the x values. Okay, so let's do quickly for the other ones. So let's say as t approaches -2. So as t approaches -2, what do we have? So you go to that t approaches -2, which is here, and then we see that it is cutting at this point. This is the only point that our imaginary line is cutting the blue graph. So we read that particular value on the y-axis, and on y-axis that is going to correspond to 0. So the answer is 0. So the limit as f of t t approaches 1, right? What did we say? 1 is here, right? The imaginary line cuts the graph or the blue line only at this point, and read that value from the axis. We have 1. So the limit as f of t as t approaches 0, right? When you look at the 0, our imaginary line through 0 is it's meeting the blue line at 2.1 and 0.2. For this one does not exist because we shouldn't have that. Does not exist. That's a trick for this one. And then the last one, limit as f of t. I mean, like t approaches what we did for -2. It's left with -1. So the answer is going to be -1 as well. Since when we are -1, the imaginary line cuts the blue line, the graph at this point, and that point corresponds is corresponding value on the y-axis is -1. Again, the limit value are read from the horizontal, the vertical axis, that's the y-axis, and then the limit value, I mean, where t is approaching, the approaching value is read on the horizontal axis or the x-axis. The x-axis in this case is labeled as t, so we go accordingly according to the question. Yeah, basically that's this is how to solve for this question using the graph to find the limit. I hope you keep this trick. Now we're moving on to find use the numerical value. Next session is going to be about the numerical value. Now that we understand how to go about the graph one. See you in the next session so that we can explore more examples that doesn't deal with the graph way of finding the limit of a function.